We're going to continue with the hyperbola, because what we've got to do is we've got to sketch a couple more, all right? Just as a practice, we're going to go through it together. And as I've said before, the way to use these, of course, is to do it with me. Go through, make your notes on. So use this as a study session and make your notes on your example as you go through it, right? Let's look at an example here. An example, sketch. Sketch f of x, g of x, h of x, t of x. Sketch the following function. Sketch the graph of, right? They're all the same. And it's going to be y is equal to 1 over x minus 4 plus 2. Okay. Step 1. Okay. Chorus, yes. Shape. A is greater than 0. Therefore, it's going to be in there, isn't it? Gotcha. Number 2, asymptotes. Okay. And we go horizontal. All right. Horizontal, right? Let's have a look. If it's the horizontal asymptote, that's Q. Therefore, y equals 2. Isn't it? And we go vertical. Okay, that's P. What can X not be? X cannot be 4. Restriction, remember? Restriction, X cannot be equal to 4. Therefore, that's an asymptote at that point. Okay, then let's have a look. What's the next one? Okay, let X equal 0. 2, 3. Let X equal 0. And we put it in and we get y is equal to 1 over 0 minus 4 plus 2, which is going to be minus a quarter plus 2, which is 1 3/4. Okay. Oh, sorry, not 3/3. Oops. 1 3/4. Don't you hate it when it does that? 1 3/4, which is going to be 7. 4 is 7 over 2. All right. And what do we say next? We say let y equal 0. Write your steps down when you do it. Therefore, 0 is 1 over x minus 4 plus 2. What do we always do? The recipe, take the 2 over, is 1 over x minus 4, and cross multiply. And we get minus 2 times x minus 4 equals 1. And what do we do with that? Our next step is with it is we say righty-ho. Multiply it out is minus 2x plus 8 is equal to 1. And eventually we solve and we get x equals 7 over 2. All right. The point is 0 and 3.5. 7 over 2. Okay. Right. Now, therefore, we can start sketching this now. They've said sketch the graph. All right, let's do that, shall we? Down there. Okay. No, I just having a look at the one I've sketched. I just need to give myself a little more space to the one side. So I'm going to say draw it over here first. And let's have a look. 1, 2, 3, 4. Whoops, 4 over there. Okay. And let's have a look now. What do we say? Well, first of all, let's put in the asymptotes, and it's at x equals 4. Right? At x equals 4 like that. And at y equals 2. Okay, so we say 1, 2. Like so. And we put in some points, and we said, okay, I'm going to put my important point down. The important point over there is going to be 4 and 2. Because that's going to help me with my axes of symmetry if they ask me. Okay, let's plot in some more points. Plot in 0 and 3.5, 0 and 3.5. There's a point. Okay. And we put in 0 and 1 3/4, 1 3/4. There's another point. And we know that it goes something like this, right? Okay, I've got to make it sort of fit. It's actually quite difficult drawing on this pad. Okay, something like that. And I just have to move it down. I just want to put this guy in over here as well. Okay, there we go. And we are sorted. What is the next? Okay, the next they say, okay, what are the axes of equations of the axes of symmetry? Let's put the question down. Okay, and they say, question B, what are the equations of the axes of symmetry? Well, I'm just going to abbreviate if you don't mind. What do? I go to my graph and I put them on there now. Okay, I'm just going to put them in blue. And where do they go? Yep, they go through this point here, don't they? Okay, and I know I've got this one down here, y equals minus x plus c, and this is y equals x plus c, and they are going to go through the point 4 and 2. Okay, so I then say my axis of symmetry that way, I'll leave it blue, and that way, this is y is equal to x plus c, this is y is equal to minus x plus c, and, oops, not SBS, substitute the important point, which is 4 and, okay, let's just go. Can you see it? 4 and 2. It's this one here. Let me just highlight it. Come on. Okay, 4 and 2. Substitute 4 and 2 in there. Okay, stay with blue. 4 and 2. So we get 2 is equal to x. Sorry. 2 is equal to 4 plus c. Therefore, c is going to be equal to minus 2. Therefore, it's y is equal to x minus 2. And over here, I substitute 2 minus 4 plus c. Minus 4 plus c. c is equal to 6. Therefore, it's y is equal to minus x plus 6. Right? Then I go back to my graph and I write them over here onto my graph. Let's go. This is going to be y is equal to minus x plus 6. And this is going to be y is equal to x minus 2. Over there. Minus x plus 6. And this one is going to be equal to, sorry, let's just get rid of that there. Y is equal to x minus 2. Is that? And you can see it's heading off down in that direction, isn't it? Okay. Just as a little follow-up, you say, okay, does it look about right? The next thing they're going to say, okay, calculate the coordinates of the points of intersection between the graph and axis of symmetry. 1, go to graph. Okay, look which one actually cuts. Let's go have a look. Right, let's go. And the one that cuts, I'm going to highlight in red, is that one. The y equals x minus 2 is the one that cuts. Then we simply go down and we put that equal to the original graph. It's y is equal to x minus 2. Okay, this one actually cuts. Therefore, I go x minus 2 equals 1 over x minus 4 and plus 2. All right, there are formulae you can remember. Take the 2 over that side. You get x minus 4 is 1 over x minus 4. X minus 4 times x minus 4 equals 1. You note there's a similarity always with these, obviously, because we're working with an axis of symmetry. And we're going to get x squared plus 8x minus 8x. 8x plus 15 is equal to 0. And if I solve it, I get x equal to 5 and x equal to 3. And my last thing is to put in, substitute for y is equal to 5 minus 1. Okay, you substitute into your axis of, into the easiest one, the x minus 2, right? 5 minus 2, sorry, not that, is equal to 3. Therefore, my coordinate is 5 and 3. And over here, y is equal to 3 minus 3, which is 3 minus 2. Okay, x equal to 3, 3 minus 2. All right, and let me just check myself there. Yeah, 3 minus 2. Sorry, I was just 3 minus 2 is 1, and my coordinates are 3 and 1. And then I go back up and I go and put it onto the thingy. And I say, those are my coordinates. Okay, let's put them in green. So you are going to be over there. You're going to be 3 and 1. All right, and this coordinate over here is going to be, I think it was 5 and 3. All right. You know, more or less, I mean, I haven't drawn them at 45, but you get the general gist of it, don't you? Okay, so determine the equations. Now, let's just have a look now. This is the next way that we're going to be asked this stuff. All right, they want us to, let me just go back to black, determine the equation from A, given points, or B, remember this, a graph. Okay, if you get a graph, you can see straight away, you put the coordinate points down, and what is the key? Look for one of the coordinate point x or y if there's a 0, because that's an intercept. All right, that is a point worth looking at a little bit further. Okay, right. They say, example. Okay, and you'll see it's exactly. Find the graph of. Find the graph of the hyperbola. Okay, you know I'm going to stop and use a red pen now, hey? Come on, red. They've told us the shape, right? Yes. Through A, okay, minus 6 minus 1, and B, 2 and minus 7 over 3, okay, and with a vertical asymptote and a vertical asymptote at x equals 3. You could go and x equals, where did I get it? X equals minus 4. X equals minus 4. Sorry about that, minus 4. Okay, step 1. What's the step 1 that we always do? Standard form. Okay, 1, standard form. Y equals A over X minus P plus Q. Fill in what we know. Look at graph. If they give you a graph, look at the graph. They might give you an x equals something, a y equals, they'll give points. So what have they told us? They've told us that there's a vertical asymptote at x equals 4. Therefore, y is going to be, so on the graph over there at x equals 4, so p is going to be equal to 4. Correct? Okay. P equals, well, it's going to be p, sorry, at minus 4. Sure, my bad. X equals minus 4. I'm thinking of a completely different graph here. X equals minus 4. So it's going to be, I've got to put in there minus p equals minus 4 minus 4 is going to be a over x plus 4 plus q. My apologies for that. All right, I was thinking of a completely different graph. Okay, so we've got that. Now we're left with a and b. Okay, what do we do? Okay, substitute a and b into what we've got there. Okay, and this is going to be two simultaneous. A is going to be minus 6 minus 1, and b is going to be 2 and minus 7 over 3. Like so. Well, what are we going to do? Okay, we are going to do this. We're going to put it into the standard form. This becomes y is minus 1 is equal to a over x is minus 6 plus 4 plus q. This side we get minus 7 over 3 equals a over 2 plus 4, right, plus q. Can you see all I've done is I've substituted the 2 in where the x was and that over there where the y is. So this leaves us with minus 1 is equal to a over minus 2 plus q. And this side we get minus 7 over 3, okay, is equal to a over 6 plus q. Right, they're going to all work out the same. Right? What do? I multiply through by the LCD times minus 2 times minus 2 times, times minus 2. This side I'm going to times by 6. Right? Because I want to get rid of the LCD as a fraction, don't I? Therefore, what am I left with? Okay, I'm left with, on the left-hand side and the right-hand side, I'm left with here, we end up with 2 equals a minus 2q. And on this side we get minus 14 because that 3 cancels with the 2 there and is equal to a plus 6q. Okay, I choose to eliminate a, so I slide it in underneath, a plus 6q. All right, label them equation 1 and equation 2. All right, you can't do the shortcuts. Okay, and what am I going to do? Okay, I'm going to take equation 1 and subtract equation 2. If I do that, I end up with 16 equals minus 8q. Therefore, q is going to be equal to minus 2. All right. Now, therefore, back substitute to find a. Back substitute where? Well, I would put it into the easy one, wouldn't you? I'd put it into the easiest one. I'd say 2 is equal to a minus 2 times minus 2. So a plus 4, 2, so that goes over, minus 2 is equal to a. Now, therefore, the equation is y is equal to minus 2 over x plus 4 minus 2. Guys, they are all the same. Okay? They are all the same. It makes no difference. That's the way you're going to do it, right? Now, in any of the scenarios, look at what you're given, put it in, and substitute. Remember that they could give you, right? Let's say, given the following graph, right? Given the following graph, given the following, I'm just going to draw it over here now, right? Put in my asymptotes. Green is 3 and x, and they tell us the graph is over here, and up there. And they tell us the coordinates of this point here are 1 and 3. All right? And 1 and 3. That's what we know. Okay? They say this graph is y is equal to 2 over x minus 1 plus 3. Okay? They want to know, okay, what is the new equation if we shift or move the graph. Okay, if we move the graph let's have a look. 8 down and 5 left. 8 down and 5 left. Remember the parabola? We took the turning point. In this one, use the crosshair point. Okay? The point 1 and 3. Right? We are going to now say down affects the y and left affects the x, doesn't it? That's going to go that way or that way. So if I'm going left or right, I'm affecting the x. If I'm going up or down, I'm affecting the y. So what do? I say, all right, I am moving 8 down. So this is the old point. So now how do I get to the new point? Quite simple. What I do is I say, okay, we shift the graph 8 down. I'll just change color. So this is going minus 8. 3 minus 8, minus 5. Okay. You are going which way? Left 5. So you're subtracting 5. So you're going to end up at minus 4. Okay. Minus 4 and minus 5. So therefore, this is the new point. What is it? It's this. Same again. It's P and Q, isn't it? P and Q is what we've got there. So the new graph is going to be y is equal to A over x minus P plus Q. What stays the same? A stays the same, so it is 2 over x minus, and it's now minus 4, minus 5. My new graph is going to be equal to 2 over x plus 4 minus 5. That's where I have shifted it to. So what have I actually done? I have shifted this graph down to minus 4, minus 5. This graph here, red, I'm going to go, I have shifted this to minus 4 and minus 5. Okay? And the whole graph has gone with it. That's all we've done. As simple as it seems, that is all we have done, right? So, whenever you get any of these hyperbolas like that, just remember, look for parabola, we looked for the turning point and we moved it. Hyperbola, look for the crosshair point, where the 2, that very important point, where our axes of symmetry go through and everything. Remember, you move it down to that point there. Okay? So, in all cases, what do? You put the standard form down and substitute in what you're given and solve. Usually it's 2 simultaneous equations in this case. Okay? That brings us to the end of that. The next one's going to be exponential functions. And I hope that throughout this process you're seeing the pattern. There's a continuous pattern of how to do these. Okay? And once you've mastered that pattern, it's not a difficult process at all. Cheers, all the best, have a great time, bye.